Okay, so let us just quickly revise what we did yesterday and go ahead. Hmm? So first thing which we did yesterday was about mean, which is sum of all the observation upon total number of observations, right? Second thing was factorial, and just this is just one example that you can like value of 5 factorial is going to be 5 into 4 into 3 into 2 into 1. Okay, and like if you like on basis of formula, we can write n factorial is n into n minus 1 factorial. Okay, and the most important thing which like from all this was NCR, or let me write clearly, combination. So NCR, so the formula was n factorial upon r factorial into n minus r factorial. Okay, and let us just quickly take one example. So yeah, let us take this easy example, 8C2. Now quickly solve this and let me know what is the answer.
28.
28. Do you know? So this is going to be 8 factorial upon 2 factorial, 6 factorial. So we'll open this till 6 factorial. So this is going to be 8 into 7 into 6 factorial upon 2 into 6 factorial. And that is, this will get cancelled. And 2 ones are 2 fours. Finally, we get 20. Okay. Is this idea clear? Ritu, Jino?
Yes.
Okay. So now let us go to the actual problems which we have from the sheet which ma'am has given. Okay, so let us start with this very first problem. Yes, did you read the problem?
Yes, sir. If a six-faced cubical die is thrown, what is the probability of even number turning up, and what is the probability of getting 4 or highest number?
So see, a six-faced cubical die is thrown. So we know in this case, uh, our sample space is tell me.
1, 2, 3, 4, 5, 6.
Yes, absolutely. Right. So number of sample points is basically 6, right? Now the first
Yes,
event
sir.
they are saying is the probability of an even number, right? Let us say that A
Yes.
is the event of getting even number. Okay. The event of getting an even number. So tell me what numbers will come in A?
2, 4, 6.
4, 6.
2, 4, 6, right? So we know that n of A is how much? 3. So our probability of A is going to be n of A upon n of S, right? That will be 3 upon 6. Both of you agree?
Yes. 1 by 2.
Ritu?
Yes, sir.
Okay. Let us solve next problem. Next part is, what is the probability of getting 4 or a higher number? Now when they say 4 or higher number means 4, 5, 6, right?
Yes.
So we can say that B be the event of getting 4 or a higher number? So tell me what numbers will come in B, set B.
4, 5,
4, 5,
6.
6.
4, 5, 6, right? So again, in this case also what we have is n of B is 3. So again, our probability of B is going to be n of B upon n of S, that is 3 by 6, that is 1 by 2. Is this clear?
Yes, sir.
Ritu?
Yes, sir.
Okay. Now, I think second one we did yesterday, right? 2 die are thrown.
Yes, yes, sir.
Okay.
We have
Chalo.
done it already.
Jinu, read the third question.
If 2 dice are thrown simultaneously, what is the probability? ये hide हो रहा है, एक second.
Of getting the same number on both dice. Okay.
Oh.
Right. So see, in here I am not writing that sample space, but in exam you must write. Madam will know that you know what you are doing. So it will start this way: 1, 1, so on up till 6, 6. Yes or no?
Yes.
So how many decimal points are there in this case? 36.
Yes.
Right, Ritu?
Yes, sir.
Acha, I just missed one thing. You should always start like this. 2 dice are thrown simultaneously. And then sample space is this, and our number of sample points is 36. Okay, now let us go to the specific question. What they're saying, same number on both sides. So let us say A is the event, or if you don't like A, you can take whatever alphabet, capital alphabet you want. Don't take S. Okay, so A is the event of getting
Number less than 2.
नहीं बच्चा, same number on both dice ना. Event of getting the same number on both dice. Fine. Tell me what number, what will be the elements in this set?
1, 1, 2, 2, 3, 3, 4, 4, 5, 5, 6, 6.
Right? So here we have n of A equal to 6. And I don't think now you'll have difficulty in finding the probability. It will be P of
Yes,
A
sir.
equals to 1 by 6. Both of you agree?
Yes.
Okay. Now, I think you can solve this fourth one on your own, Ritu.
Yes, sir.
If two coins are, if a coin is tossed two times, so what is probability of getting same face? So we know that when we toss a coin two times, we'll have head, tail, tail, head, or tail, tail, right?
Yes, sir.
So let us just do this quickly. So a coin tossed two times. So we know that the sample space is going to be head, tail, tail, head, tail, tail. Okay. N of S is 4. Now what they want, same this thing, right? They said something. What is the question? 1 minute, I'll just see the question again. Same face. This means they want head or tail, right?
JJ.
No problem. right? So probability will be in this case 2 upon 4, that is 1 by 2, right? Jinu, Ritu,
Yes, sir.
Yes,
okay.
sir. Yes, sir.
So I don't think so. Are these 4 problems clear? First of all, I know this is the like difficult problems, but still,
Yes, sir. It
hmm?
is.
Okay. So just before we
Yeah.
move on to, yes, tell me, it's clear. Okay. So before we move on to other problems, let me just uh, talk about something, because again and again these things are going to come. Okay. So let's just talk about them once. So let us talk about coins. Okay. So we will have like case of one coin. So in case of one coin, tell me what is sample space.
Head and tail.
Okay, so please don't use and, because mathematical and means both are conditional satisfied. So when you toss a coin and
Yeah, yeah.
okay, so please use the term or, head or tail, right? So
Yes,
how
sir.
many how many sample points are there here? Two. Yes, Gino. So when we have number of points as one, sample space is head or tail, and number of sample points are two. Now, if you take two coins, yes, Janvi, tell me.
HH, TT, HT, TH.
Okay, so here we have four. Now, yes, Ritu, tell me. When you take three
So
coins,
just a second. Just a second.
hmm,
HHH, head, tail, tail, head. Three times tail, head,
okay,
tail,
one.
head,
I'll
tail.
just write neatly. 1 minute. Tail, head,
Yes.
yes.
Tail, head, then tail, tail,
Tail, tail,
tail,
tail,
tail.
head, tail. Okay, so these are eight, right?
Yes, sir.
So now I want both of you to tell me the pattern. And I know that it is not difficult. See, 2 is nothing but 2 raised to 1.
Yes, sir.
4 is nothing but 2 raised to 2.
Yes, sir.
Yes, now tell me, Janvi. Jinu. Okay, Ritu.
Yes, sir.
Yeah, tell me 8 is 2 raised to how much? 3, right?
Yes.
8 is
2 into
nothing
2
but 2
into
into
2.
2 into 2, right?
Yes, yes.
Now, can you see some pattern in this? When we have one coin, we have sample points are 2 power 1. When we have two coins, sample points are how many? 2 power 2. When we have three coins, sample points are how many? 2 power 3. Yes or no?
Yes, sir.
Yes, sir.
Hmm? Now, if we have four coins, tell me how many sample points will be there? 2 power 4.
2 power
That
4.
is that is 16, right? So if we have
Yes.
five coins, it will be 32, which is 2 power 5.
Yes, sir.
Yes or no?
Yes.
Yes, sir.
Is the idea clear? See,
Yes,
we are not writing the sample space for 4 coins and 5 coins, but is the answer idea clear? How we will find number of sample points in those cases also? Okay, no problem. Just take a minute and go through this idea of coins, and let me know if you have any difficulty.
No doubt, sir.
Okay, Jinu.
No doubt.
Okay, fine. Similarly, let us talk about uh, so coin is over. Let us talk about die. So in case if we have one die, the sample space is 1, 2, 3, 4, 5, 6, right? And number of sample points are how many? 6. Yes or no?
Yes.
Hmm? On similar lines, when we have two, like when two die are thrown, we have sample points will be how much? We start from 1
Well,
comma 2, so on till 6 comma 6. Yes or no?
yes.
And these are 36. Yes or no?
Yes, sir.
Now can you again see some pattern? 6 is nothing
Yes,
but
sir.
6 raised to 1. This is 6 raised to 2. Yes or no? So
Yes, sir.
let us assume that if if three die are thrown, sample space will start something like this: 1 comma 1 comma 1. It will go up to
6 cube.
6 comma 6 comma 6, right?
Yes,
And
sir.
this is going to be 6 raised to 3. And now you can use your mobile phone and tell me the answer.
216.
Okay,
216.
216. Okay, so both of you agree here?
Yes, sir.
Hmm? Okay, so see, I know that both of you know about the pack of well shuffled card, but let me just show it to you once and then we go to the problems once again. Okay, so we know there are 52 cards, right? And in this 52 cards, we have two colors. One we have red, these are 26, and we have black, they're also 26, right? Now in this red, we have two suits. So one suit is diamond,
Diamond.
and other suit is of hearts. Okay, and here in black we have club,
Spade and club.
yes, spade, and we have club. Okay, and now within each of them we have numbers. Like first we have ace, then numbers 2, 3, 4, 2 to 10. We have numbers. Then we have king, queen, jack. Similarly, here also we have ace, numbers 2 to 10. Again, king, queen, jack. Okay, and here again similar. So on same lines we have ace, numbers 2 to 10, king, queen, jack. Again in club we have ace, numbers 2 to 10, king, queen, jack. Okay, now one very important thing which will come again and again is about face cards. Okay, so these king, queen, and jack comes under face cards. Okay, so these are basically face cards. One minute. Let me just search for the cursor. Okay, so these are face cards. Okay, now let us again go back to our problems which ma'am has given us. Okay, is this structure clear to both of you?
Yes, sir.
Okay. So let me take this problem of cards only, because just now we have done the card is the recent thing we have done. Okay, so I think this is question number 9. Okay, now I think it's Ritu's turn. Yes.
Yes, sir.
Yes, Ritu, go ahead.
One card is drawn from a full well shuffled pack of cards. What is the probability that it is a jack and it is a red card?
And see, like, don't take me wrong. It is not just pronounce it the jack again.
Jack.
Okay. Fine.
Yes, sir.
So we want it to be a jack, and once in the other case we want it to be a red card, right? Okay. So we know there are 52 cards.
Yes.
And now tell me, Gino, how many cards are jack? Like, how many are jack in this?
13.
Bacha, jack.
4.
There are 4 jack. Therefore, probability of getting a jack is how much? 4 upon 52? That is 1 upon
Yes.
13.
1 by 13.
Both of you agree?
Yes, sir.
Okay. Ritu, now next part is red card. Tell me, bacha, how many red card?
26.
There are 26 red cards. So,
26 upon 52, that is 1 upon 2.
right? So let me not wait. Let us save our time. Clear? Okay.
Yes, sir.
Yes.
So now what I want is both of you take 5 minutes and try these problems 10, 11, 12, 13. Whatever number of, like, maybe 1 or 2 problems you may be able to solve completely. Try 10, 11, 12. Try, and I will again continue after 4 5 minutes. Okay, just let me know once you are done that trying work. Okay, so let us look at 10th one first. Yeah, you are trying 11th problem, right? Ritu?
Yes, sir.
Okay.
Yes, sir.
So let us do that only first. See. So 11th question is that we have to take 3 cards, right? And what is the probability that all of them are red cards, right? Hello, that is the question, right?
Yes, sir.
Let us do that problem. So you know that there are 52 cards. So in how many ways we can choose 3 cards? We can choose 3 cards in 52C3 ways, right? Remember that combination thing we talked about?
Yes, sir. Yes, sir.
Okay. Now there are how many red cards?
26.
26. So again, we'll mention that there are 26 red cards. Okay, and again we'll write that statement. We can choose 3 red cards in 52, oh sorry, 26 C3 ways. Is this clear?
Yes, sir. Yes, sir.
So probability of choosing 3 red cards is 26 C3 upon 52 C3. Yes or no?
Yes, sir.
Yes.
Is this clear to both of you? Good. Now let us
Yes.
do this calculation separately and let us just put those numbers over there. Okay. So I want, like, even in exam, don't do this calculation somewhere towards the end of the question paper or answer sheet. Please do on the same page. Just draw some margin or something like that and do it over there itself. Okay. Let us do it clearly. So this is 26 factorial upon 3 factorial 23 factorial. Yes or no? Both of you agree?
Yes,
Yes,
sir.
sir.
This one we will open till 23 factorial.
Yes.
2600.
And this is 3 into 2 and this is 23 factorial once again. And this will get cancelled. 2 ones are, 2 12s are, 3 ones are, 3 4s are. Finally it is 260, right? Sorry, 2600. Okay.
Yes, sir.
Yes.
And here we have 52C3. That will be 52 factorial upon 3 factorial of 49
It's
factorial.
22,100.
How much is it? Is
22,100.
1100. Okay, so 2600. So just see if it is matching with the ma'am's answer.
Yeah, 2 upon 17. Ma'am answer is something else. I think it's wrong.
No, don't say that. Hmm. 6 upon, no, ma'am's answer is 6 upon 51, right?
Yes, sir.
Maybe there must be some that this is divisible by 13, right? And let us see
It's
if
2
this
upon
is
17.
this answer comes up to 2 upon 17.
Yes, sir.
Okay, and ma'am's answer is
6 upon 51. She only said that there are many
but
answers
see,
which doesn't match.
see, this is no. See, this is basically 2 3s are and this is 17 3s are, right? So again, this will become 2 upon 17 only. Are you getting the point?
Okay. Yeah,
So it
yeah.
is not about wrong, it is just different representation. Okay.
Yeah.
Okay. Now let's come to this 10th question. Ritu, tell me, like, we should stop now or we can continue?
No, sir, we can continue for more 10 minutes.
Fine. Let us jump to this 10th question now. Okay. Now see, for this 10th question, we need little common sense. So the question is, yes, Janvi, read the question.
If two cards are drawn from a full pack, what is the probability that they are from different suits?
Now, see, there is no problem in choosing the first card. Okay. Our choice will only reduce to the second card. In second card, let me say that in the first case, I choose something from my favorite is spade. Okay. So that is choice is done. Now, how many cards are there from which I can choose?
4.
One.
No, bacha, see, there are 52 cards, right?
Yes,
Yes.
sir.
I have taken a card from spade. Now total cards are remaining how much? 51.
Yes.
And now I cannot choose again from the spade.
Yes.
So now how many are non-spades? 39.
Yes, sir. 26
Okay,
plus 13.
Is this clear? Is the idea clear, first of all?
So can you explain this again?
No problem. See, there is no problem with the choice of first card. The problem is only going to come in this case. See, this case is very different. Huh? The problem is only going to come to in the second case. Second case, what is going to happen? Once I have chosen one card, let me assume that I am choosing from hearts. Okay.
Yes, sir.
Now, if I take one card from the hearts, one card is taken, so the one card will get reduced. So instead of 52 cards, now we have to choose from 51 cards, right? I have taken that heart
Yes, sir.
from the let me say I have taken ace of hearts. Okay.
Okay.
So that is card is done. So I cannot choose from this suit, heart suit, right?
Yes, sir.
So now how many cards are there from which I can choose now? 39.
26 plus 12. No,
13.
13. Because now I
Okay,
can
हाँ.
choose from spade, I can choose from club, I can choose from diamond, right?
Yes, sir.
And now one card will get reduced. So how many cards are there now? 51.
51.
Now is the idea clear now?
Yes, sir. Yes, sir.
Okay. Okay. Now you both of you try this 12th problem.
So what is the written format for the question number 10?
I'll write, don't worry.
Okay.
Wealth sum is done.
You can try the 13th sum by that time.